Hello students, welcome back to the channel. Students, in this video we are going to study the meaning and formula of a very important term which is called electromotive force, and in short it is called as EMF, right? So what is EMF or electromotive force of a cell? It is the potential difference between the two terminals of a cell in an open circuit, that is when no current is drawn from the cell. What is the meaning of this statement? You all must have seen a pencil cell which you use in remote controls or toys. You must have seen the value 1.5 volt written on the cell. So if 1.5 volt is written on that cell, it means volt is simply joule per coulomb, so we can read it as 1.5 joule per coulomb, right? 1.5 joule per coulomb, which means that if you apply this cell in a circuit, then it is going to give an energy of 1.5 joule to a charge of 1 coulomb, and using that energy, charge is going to move in the circuit, and that what makes the current in the circuit, which is used to glow or run the objects which are connected in the circuit. So if in this case, suppose your charge of 1 coulomb is getting an energy of 1.5 joule, which is not suppose enough to run the circuit or the components of the circuit, then in that case we use two cells in series, which makes 1.5 plus 1.5 total energy as 3 volt. Now if we read 3 volt as the meaning of 3 volt, which is 3 joules per coulomb, now we see that 1 coulomb of charge is now getting 3 joule of energy. So if the same amount of charge is getting more energy, so obviously it is going to move more rapidly, and that means the current in the circuit will increase, right? So in some toys or in some remote controls we use two cells, and in some toys when there is more functionality we use 3 cells, and that is the reason behind it. Okay, so this 1.5 volt which is written on the cell is called the EMF of the cell, electromotive force. It is not the force, it is basically the energy which is given to 1 coulomb charge, right? But why we are calling it a force? Because this energy is used to push the electron, and what is the agency which is used to push something, that is called force. That's why we are using the term force, but basically it is energy, right? So this is a force which is motivating the electrons to move in the circuit. That's why it is called the electromotive force. So okay, now what happens when suppose 1.5 is written on a cell, and when you use that cell in a circuit, you are not going to get 1.5 volt as potential difference. It's because every cell has something which is called the internal resistance. What is resistance? We all know that resistance is a property which opposes the flow of current through a circuit, right? So every cell has an internal resistance, so it has to overcome that internal resistance by using its own energy. So if the potential of the cell is 1.5 volt, and out of that 1.5 volt, suppose 0.1 volt is used by the cell to overcome its own internal resistance, then only 1.4 is left to be used in the external circuit, and that 1.4 is called the terminal potential difference. If you are not using the cell in a circuit, then obviously the potential difference between the two terminals is 1.5 volt, which is written on the cell. But when you are using that cell in a circuit, then the potential difference reduces by some value, and that value is used by the cell to overcome its own internal resistance, and the rest value is used in the circuit, which is called the terminal potential difference. Suppose you are eating some food, and that food is giving you an energy of suppose 100 joules. So you are not going to use that 100 joule energy for running. You will use some part of that energy for your internal activities like respiration, like transportation, right? Suppose you are using 20 joule of the energy of out of that 100 joule for the internal activities of your body, then you are left with 80 joule of energy, and that 80 joule of energy will be used by you for running. So this is what happening in this cell. So terminal potential difference, it is the potential difference between the two terminals of a cell in a closed circuit. That is when some current is drawn from the cell, right? Okay, now let us say that the external resistance, whatever is connected in the circuit, the external resistance of that thing is R and the internal resistance of the cell is R, right? And the EMF of the cell is E. So current in the circuit is I, right? Current in the circuit is I. So what is the potential difference across the external circuit, which is the terminal potential difference? The potential difference across the external circuit using Ohm's law can be said as V equal to IR, right? So if I is the current which is flowing in the circuit, then the potential drop, the part of the potential which is used by the cell to overcome its internal resistance, that will be what? Again using Ohm's law, that will be I into small r. So potential difference at this part is I into small r, which is used by the cell to overcome its own resistance. So the total voltage that is applied is E, right? And out of that E, this V is being used here, and or we should write, yes, out of that E, V is used here and IR is used here, right? So we can say then this is the formula for EMF of a cell. If we know the external potential drop, the potential drop across the external resistance, and we know the internal resistance of the cell, and we know the EMF, the current flowing in the circuit, we can find the EMF of the cell. But generally we are supposed to find the terminal potential difference in questions, which is V equal to E minus IR, which is V equal to E minus IR, right? So this is the relation between EMF, terminal potential difference, internal resistance, and all those things. We will say that this is the equation in case of discharging. Discharging is simply a process when you are using the cell, because when we use a cell in a circuit, it gets what? It gets discharged with time. And there are some cells like the battery of our mobile phones, and there are some pencil cells also which are chargeable, right? So what happens during charging? During charging, what happens? We flow the current during charging. What happens? Using the external circuit, we flow the current in the cells in the opposite direction to what the direction was when the cell was discharging, right? So what happens? Cell is simply what? It is simply a chemical reaction and nothing else. Some reactants were converted into products when the cell was discharging. So when we flow the current in opposite direction, then that reaction, which is reversible in nature, takes place in opposite direction, and the products and the reactants that were converted into products, those products gets converted back into the reactants, and we get all the reactants back, which when we get all the reactants back and nothing is left as a product, we say that the cell is fully charged and it is ready to be used in the circuit again. So what happens if you flow the current in opposite directions? Then obviously instead of I, you are going to take minus I, so this equation becomes E plus IR. Or we can simply say that if the potential drop across the cell is 0.1 and the EMF of the cell is 1.5, then you have to give a potential difference of 1.6 to charge this cell, because if you give it 1.5, then the 1.1 will be used by the cell to overcome the internal resistance, and for its charging only 1.4 will be left, but the EMF of the cell is 1.5, so it needs complete 1.5 for charging, and for that you have to give an external voltage of 1.6. so that out of that 1.6, 0.1 is used to overcome the internal resistance and 1.5 is completely left for the cell to get charged, right? So this was the concept of EMF, terminal potential difference, charging and discharging. I'll meet you in the next lecture. Till then, all the very best.